Dear students, let us begin with our second part. Here we are going to learn on computations of expected frequencies of 2x2 contingency tables and Yate's correction. To compute the expected frequencies of 2x2 contingency table and to apply Yate's correction, we will be following the steps. First, you have to obtain the observed frequencies, collect the actual counts or frequencies for each cell in the 2x2 contingency table. Let us denote these observed frequencies as O11, O12, O21 and O22. As you know that it is a 2x2 contingency table, it means that you will be having 4 different cells. So, the 4 different cells has been written as O11, O12, O21 and O22. That is, it means that first row first column, first row second column, second row first column and second row second column. These are all observed frequencies. Calculate the row totals, that is total counts for each row by adding the observed frequencies. So, denoting the row totals as R1 and R2, as I mentioned that it is a 2x2 table, we will be having 2 rows, whereas R1 and R2, where your R1 sum can be obtained through O11 plus O12, that is your row 1 total. Similarly, R2 can be obtained as O21 plus O22, that is your row 2 total. In the similar fashion, you can calculate for our column totals, that is computing the total counts for each column by adding the observed frequencies. As I mentioned, it is a 2x2 where we will be going with 2 columns C1 and C2, that is column totals. Then your column total C1 can be obtained by O11 plus O21, that is your column 1 total. In the similar fashion, C2 will be O12 plus O22, that is your column 2 total. So, up to here you are able to frame your 2x2 table with your row total and column total, and you can also obtain your grand total too, that is calculating your overall total summing up of all the observed frequencies, that is denoting the grand total as T, capital T, that is your T will be O11 plus O12 plus O21 plus O22. As I mentioned that your O will represents as your observed frequency. To compute your expected frequency, let I am denoting it as an capital E without Yate's correction. The expected frequency for each cell is calculated based on the assumption of independence between row and column variables. Here to calculate the expected frequency, E11, which represents first row first column, will be calculated as the row total into column total by grand total. So, since it is in the first row and first column, we can pick the first row total multiplied by first column total divided by the grand total capital T. Similarly, E12 will represents the first row second column, that is E12, you can pick up the row 1 total into column 2 total divided by grand total T. Similarly, E21, that is second row and first column, you can pick the row 2 total multiplied by first column total divided by grand total capital T. Then E22, that is your second row second column expected frequency, can be calculated by picking row 2 total R2 multiplied by column 2 total C2 divided by grand total capital T. By these 4 values, you are able to obtain the expected frequencies as like your observed frequencies O11, O12, O21, O22. Yate's correction is used to adjust the expected frequencies when dealing with only 2x2 contingency table, which helps to mitigate the effect of small sample sizes. Whereas in Yate's correction, there will be a smaller modification in calculating the expected frequency as E11 corrected, which will be calculated by maximum of 0, absolute value of E11 minus 0.5 into significance of E11, where you can compute your first expected frequency, that is your E11. In the similar fashion, you can move on to E12 corrected as maximum of 0, absolute of E12 minus 0.5 multiplied by the significance of E12. Then E21 corrected can be calculated by maximum of 0, absolute value of E21 minus 0.5 multiplied by significand of E21. Then finally E22, that is your last expected frequency, second row, second column, E2 corrected, can be computed through maximum of 0, absolute value of E22 minus 0.5 multiplied by significance of E22. The expected frequency E represent the values that would be expected under the assumption of independence between row and column variables. By comparing the observed frequencies O to the expected frequencies capital E, you can assess the association between the variables using statistical tests such as chi-square test. As earlier you have been mentioned that the comparison between the observed and expected frequencies can be moved on through our chi-square test. So here the degrees of freedom can be computed as number of rows minus 1 into number of columns minus 1, whereas here I already mentioned that it is a 2 by 2 table. It means that 2 rows and 2 columns. So 2 minus 1 into 2 minus 1, which will be equivalent to 1 degrees of freedom. Earlier in our chi-square part, we have been calculated the degrees of freedom as n minus 1, whereas here it is your two-way contingency table. You are representing it as an number of rows minus 1 into number of columns minus 1. So defaultly for a 2 by 2 contingency table, the degrees of freedom will be equivalent to 1. Let us can see some example here. Let I have been chosen a treatment method here, that is the column represents the new type of treatment and conventional type of treatment, whereas here what about it is favorable and not favorable has been chosen, and you have been went with the total here, whereas you can see the number 60 represents, that is the 60 number of people were convenient with the new treatment, that is they have been favorable with the new treatment. In the similar fashion, 30 number of people has been not favorable for the new treatment, whereas here the 40 represents the conventional treatment is favorable. Similarly, the 70 represents the 70 number of people are not favorable with the conventional treatment. And one more interesting part is that here the totals will speak about the individualities, that is the 90 represents that how many number of people are taking new treatment, that is 90. Similarly, 110 will speaks about how many number of people are taking conventional treatments. Then similarly 100 will speaks about the favorable cases, and similarly here the 100 speaks about the not favorable cases for the persons, and finally the 200 will represents about your overall number of cases, that is your grand total. Now we can calculate your expected frequencies as we have mentioned the formula, that is your row total into column total by grand total, whereas you can look over here, you are having the favorable and not favorable situation, then you are having new treatment and conventional treatment here. Now you can go for the calculation for the first expected frequency, that is your E11. Already I mentioned the formula that it should be the row 1 total, that is 90 into column 1 total into 100 divided by grand total 200, which means that 45. That is the expected frequency E11 is 45 number of persons are favorable with new treatment. In a similar fashion, you can move on to the second one, E12, that is first row second column, that is your row total is 90 here into column total is 100 divided by grand total, which will be equivalent to 45. Again here the 45 represents the 45 number of persons are not favorable with the new treatment. Then coming out to the next one, conventional part here, that is your R21, that is your second row first column, that is 110, that is 110 is your row total into 100 is your column total divided by grand total is your 200. You are obtaining it as an 55. It means that 55 number of persons are favorable with conventional treatment. Similar fashion, R22, that is second row second column has been calculated with the row total 110 into 100 divided by 200, which will be equivalent to 55. Here you have to remind that these numbers 90, 100, that is your row total, column total, which has been obtained from your previous, that is your observed frequencies, not from here. But by summing up of these values, it has to be matched with our observed frequencies. Earlier in our observed frequencies, we got 90, 110 as the totals. Similarly, 100, 100 as the totals. The grand total is 200. These total values has to be matched with the previous observed frequencies. It will be defaultly matching with the calculations here. Dear students, we come to the end of part 2 in this lesson. We have been discussed in the construction of 2 by 2 contingency table and how to calculate the expected frequencies. I am confident that you understood all the concepts and we will continue in the next video. Thank you.